Hi everyone, welcome back to the Microsoft in 29 days self-paced course. I hope that your preparation is going well for the product-based companies. In case if you have not registered for the Microsoft in 29 days self-paced course, so you can find the course link in the description of this video, and after you register for this course, then you can get access to all the days that are there in this particular series. Like you can see that we have various days. Let's say if I click on day 15, so you will get access to, as you know, you'll get access to the 2 recordings, 2 problems that we do as classwork, and other 3 problems as homework. So total 5 problems will be given to you for the submission purpose as well. And apart from this, one more thing that you can observe is we have the leaderboard where you can keep a track of your progress regarding the series. So now let us discuss this problem, that is flood fill algorithm. So the problem has been asked in a lot of companies as well. The problem says that an image is represented by a 2D array of integers, and each integer represents the pixel value. Okay, so we have been given a source row and source column with the starting pixel at this cell, and we have to do what we have been given a new color. So every cell in the grid which has the same color as the starting color, and if you are able to reach them, then you will color them with the same color as the new color. So let's quickly check this test case out so that we can understand this better. So let us say that if we have been given the test case as 1, then 1, then 1, then we have been given 1, 1 and 0, and we have been given 1, 0 and 1. And suppose that the starting source row and the source column, suppose source row is given as 1 and source column is given as 1. So basically this indicates, according to a zero based indexing, this will be the cell 1, 1. Okay, this will be our cell 1, 1. So what we will be given is, we'll be given the source row, that is the starting row column, that is this particular cell, and what we have to do is we have to color it. So we'll also be given a new color, right? So the new color that we want to do for it is nothing but 2. So suppose if the source row and if the starting cell is having the same color as the new color, so in that case you will simply terminate, you will not make any updates. But like if you start from here, so what is the start color? The start color is nothing but 1, okay, because this is the starting color. So what you will be doing here is, you will be simply moving in all the 4 directions. Let's say you move up, you move towards the right side, you move towards the down direction, you move towards the left direction. So all possible directions. Let's say in general you can move towards the left, then you can move up, then you can move right, then you can move down. So you're able to move in all the 4 directions, and what you have to do is, you have to color all those cells which are having the same color as the starting color. You can color them with the new color. So first of all, if we start from this cell, so we'll mark its color as 2, so we'll update its color as 2. And let's say if I go in the left side, so if I go in the left side, so when I go to this cell, so its value will be changed to 2. Okay, then if I go to its left, it is not possible. If I go to its upward direction, so actually there is a 1, so I can change it to nothing but 2. Okay, then if I go to the left, it is not possible. If I go to the upward side, it is not possible. Then if I go towards the right side, then I get a 1. So I will update it and update it to 2. Then for this cell, if I go to the left side, it is already 2. It is already having the same color as the new color. So in that case, I will return back simply from it. If I move in the upward direction, so actually it is not possible. If I move in the right direction, so the cell is having the value as 1. So I'll update it to 2 because it is having the same value as the starting value. So I'll update it to 2. Can I go to this direction for it? No, I cannot go to the left. I cannot go to the upward direction. I cannot go to the right direction. Can I go to the down direction? If I go to the down direction, then the cell value is actually 0, which is not same as the starting color of the cell. So in that case, I will not update it and return back from this call. So I can see that for this too, I have made the recursive call in all the 4 directions. Then I come back. When I come back, so one recursive call downwards was left. If I make the downward call from this cell, so I can see that it is a 2, which is having the same color as the new color. So I'll not update it. Come back. So let's come back. Now for this 2, I had made a call in the left direction, in the upward direction, in the rightward direction. If I call in the downward direction, downward direction is having 2, which is same color as the starting new color. So in that case, we'll not update. Then I come back to this cell. I've called for the left, I'll call for the up. If I call towards the right, so it is actually 2. So I cannot update it. So I'll come back from there. Then if I move down, then actually there is a 1. So I can update it to nothing but 2. Once I update it to 2, so I'll try to move in the left. Not possible. If I move up, not possible because it is already 2. So I'll not color it again. If I move towards the right side, so there is a 0. And if I find a 0, so what can I say? If I'm getting a 0, so basically it is not having the same value as the starting cell, right? So in that case, I'll not update it and I'll come back. Then if I move down, So actually this call is also not possible. Okay, then I come back to this 2. So for 2 I have made all the calls, then I come back to this starting cell. Okay, the starting cell from where which everything started. So for this I just had called for the left. Now I'll call for the upward direction, not possible because it is already 2. If I call in the rightward direction, it is 0, which is not the same as the starting color, so I'll not update it. Then if I go down, it is 0, which is not same as the starting color, so I'll not update it. And after this, what happens? You will see that our grid looks something like this. Our grid looks like 2, 2, 2. Then it looks like 2, 2, 0. Then it looks like 2, 0, and 1. Okay, this is what is happening with this particular grid. And after this, if I observe, so what is happening? We can easily see that our grid has got updated, right? The flood fill has been performed, and then we can simply end. So this is how we can do it in recursive manner. We can move in all the 4 directions and one by one keep on coloring them. And if I fall out of the grid, then I will return. Or if the cell that I want to, if the I, jth cell that I am currently at, if it is having the same color as the new color, in that case I can simply return because it is already colored. Otherwise it is having the same color, like if it is having the same color as the start color, then I'll color it, and for that particular cell I'll move in all the 4 different directions. So let us quickly write the code for this particular approach. So what I will be having is, first of all, I'll be having a n that will tell me the number of rows. So n will be nothing but the image dot size. Okay, and I will have m is equal to the number of columns, that is nothing but the image of 0 dot size. Okay, that is what I will get. After this, what we will do is we'll call the recursive function. Initially we'll start from the source row and the source column, and we also need to have the starting color. So we'll say that int start color is equal to nothing but the image of image source row and source column. Okay, that is all updated. Then what will happen? I'll pass the source row, source row and source column. I'll pass n. Okay, I'll pass m. Then I'll pass the new color as well. Okay, like first of all I'll pass the start color, then I'll pass the new color as well. Okay, in this function. And now my image will get updated because I'll pass it by reference. So let me pass the image as well. So I'll pass our image as well. After this part is done, so once it gets updated, so we'll simply return it. Okay, now what we will do is we'll have the recursive function in which we'll be writing the rest of the code. So what we will do here is we will have a void recursive function in which first of all I'll be having int I, then I'll be having int j, then I'll be having int n, then I'll be having int m. Okay, then what I'll be having is I'll be having the int start color, so I can say that start color I'll be having. Apart from this I'll be having the int new color. Okay, apart from this I'll also be passing the image, so vector of vector int ampersand image is what I would pass here. Then what I will do is I will simply say that if I fall out of the grid, right, what are the situations? So you have to understand what are the situations. Suppose this is a particular grid that I currently have. So when can I move out of this grid? So suppose my I is 0, right, I'm standing here, and j is something. So if I fall out of the grid here, so that means I becomes what? Negative, right? Or if I fall out of the grid from here, right? So that means if I is equal to, let's say, n minus 1, so if I becomes n, right? So in that case I fall out. If I fall out from the grid in this case, or if I fall out from the grid like this, suppose this is j is equal to 0, if this is j is equal to 0, then if I move towards the left side, so j becomes negative, so in that case also I'll fall out. Or if this is j is equal to n minus 1, m minus 1 according to 0 based indexing, so the moment j becomes m, then also I fall out. So these are the conditions when I fall out of the grid, then also I need to return. So if I is lesser than 0, or it happens that j is lesser than 0, or it happens that j becomes m or I becomes n, in either of the cases I fall out of the grid. Okay, or it happens that the image of ij, right, it's not equal to the start color. If the current image color is not equal to the start color, like if I tell you this thing, so let's say we had a particular grid. Okay, if we had this particular grid, and suppose I reached a particular cell with the value as, let's say, 3, and my start color instead was, let's say, 1. So in that case it is not same as the start color. So if it is not same as the start color, so I'll not color it. Okay, I'll simply return. And other case could be that suppose I call and I reach a cell which is having the value 2. Let's say 2 is nothing but the new color to which I wanted to paint it to. So if it is already having the same color as the new color, then I will then that means it is already updated, and I'll not update it. So if the image of ij is not equal to the start color, or the image of ij is equal to the new color. So if I've already colored it, then I'll not go through it again, and I'll simply return from this particular recursive call. Otherwise, I'll call the recursion in all the 4 directions. So first of all, let's say if I call in the, like, if I have a particular cell, suppose if I have this particular cell, so what can I say? If I am at a cell, suppose that if I'm at a cell, let's say this is the cell that I'm at, if I'm at I comma j. Okay, so if I'm moving up, so this is I, this is j. So if I'm moving up, so that means I is getting decremented by 1, I minus 1 comma j. This will be the new cell location. If I'm moving down, so that will be nothing but I plus 1 comma j. J will remain the same because the column still remains the same, right? So let's do it for the upwards and the downward direction. So if I'm moving up, so I minus 1 comma j comma n comma m comma the start color comma the new color is what I would pass, and after that I'll pass the image as well along with it. Then if otherwise I can call recursively in the downward direction. This is when I was going up, now this is when I'm going down. J I plus 1 comma j comma n comma m comma the start color comma the new color, okay, comma the image, right? After this this was for the first call was when I was going in the upward direction, right? The second call is when I'm going in the downward direction like this. So let's quickly write it. After this, if I go, let's say, in the leftward or the rightward direction. So if I go in the left, suppose I'm having a cell, okay, now what I'll do is, if this is the cell I comma j, right? So if this is the cell, this is j and this is I. So if I'm moving to the left side, so that means I comma j minus 1, I'm moving to one cell back, okay, this is j minus 1 and this is j plus 1, okay. So I'm moving to the right side, so that will be nothing but I comma j plus 1, okay. Let's quickly write the code for it. So I comma j minus 1, if I'm moving to the left, comma n comma m comma the start color comma the new color I'll pass, and I'll pass the image as a reference as well, okay. Then what we will do is we will simply say that this is when we are going in the leftward direction, okay. Now we can also go in the rightward direction, so we'll pass I comma j plus 1 comma n comma m comma the start color comma the new color comma the image, right? That is what I would pass from here. After this part is done, so this is when I'm going towards the right side. So that these are the calls that I'll make, and simply after this I'll return the image after the recursive calls are over. Let us try and compile this code to see if there is any error in this code. Let's see how it works. Okay, so we are getting some compilation errors here. Okay. Yeah, one more thing we did not do, one more thing that I forgot to do is changing the color of the cell, right? If I visit a particular cell, so I need to change its color to the new cell. So I'll say that image of ij would be equal to nothing but the new color. That is also one thing that I needed to update. And if I see here, so maybe I might have made some mistakes. Okay. So let's quickly compile this to see what were the errors. So it was giving an error in the assignment part. Okay, so I was just doing equal to, I should have done equal here. Let us try and compile it now. It works on the samples. Let us submit this code as well and see what output we get. So you can see that our solution was able to pass all the test cases. Now talking about the time complexity of this particular approach. So the time complexity of this approach would be nothing but order of n cross m, because we are iterating through each cell exactly once and changing its color if it is possible. And the space complexity in the worst case, if you will not consider the recursive stack space, so you are not using any extra space, so you can say it is order of 1. Thank you for watching this video. In this video, we will discuss the problem rotten oranges. The problem previously has been asked in a lot of product-based companies. So the problem says that we'll be given a grid which will be of the dimension n cross m, where each cell in the grid can have the values as 0, 1 or 2. And in this problem, it says that 0 represents an empty cell, okay? So each cell can either have 3 values. 0 represents an empty cell, okay? 1 represents a fresh orange, you can say, right? And 2 represents a rotten orange, okay? 2 represents a rotten orange. Now in this part, we have to determine what is the minimum time required to rot all the oranges. Like we will be given the grid, we'll be given the 2D grid, which will have some zeros, some ones and some twos. So we have to determine that whatever number of ones we are having, whatever fresh oranges we are having, what is the minimum time to rot all the fresh oranges, right? and a rotten orange at the index side. So the problem says that basically how will the rotten orange, like how will the fresh orange get affected? So if suppose that there is a rotten orange which is standing at an index I comma j, so it will rot or it if there is a fresh orange in the upward direction, directly in the upward direction one, if I go one up, and it is if there is a fresh orange in this direction, or if there is a fresh orange here in the adjacent right cell, or if there is a fresh orange in the adjacent down cell, or if there is a fresh orange in the adjacent left cell, so in that case what will happen, those fresh oranges would become rotten, and in turn those fresh oranges will also make other fresh oranges rotten. Okay, that is what is going to happen. So let us quickly discuss the sample test case that has been given to us. So what we have been given is, we have been given this particular data, that is we have been given 0, we have been given 1, then we have been given 2, then we have been given 0, again we have been given 1, then we have been given 2, then we have been given 2, then 1, and then 1. Okay, this is the data that we have been given. So basically if we see, so this is one rotten orange, this is one rotten orange, this is one rotten orange. So for doing this problem there can be various approaches, but the most optimal approach for doing this problem can be using the breadth first search approach. We can simply apply the breadth first search approach and we can do it in minimum time possible. Okay, how? So first of all what we will do is, we will make a queue in which we will store all the index of all the elements that are having the index of all the cells that are having the rotten oranges. Okay, here it is having a rotten orange, right? After this what we will do is, after inserting these inside our queue, what we will do is, we will take them one by one out. So suppose this was first inserted, so for this particular cell, if I go in the upward direction, so can I, like if I go in the left direction I cannot rot any orange, if I go in the upward direction I cannot rot any orange, if I go in the downward direction as well I cannot rot any orange, but if I go in the rightward direction, so that means I can rot one orange. Okay, and notice that currently time is equal to 1 only, right? Currently the timer is only 1, so I can rot this orange. So basically I'll rot this orange. Okay, and then I'll insert this particular orange into my queue as well, this particular index as well, because it will affect the other oranges, right? After this, this 2 has been done, so rest of the 2s that are there, they will also do in time t is equal to 1 only. Other oranges that were on the same level, they will do the job. So if this rotten orange, so I can say that if I talk about this, so it will rot this orange, so that means this orange becomes nothing but 2. Okay, so now I'll highlight it with blue, indicating that it will be marked as 2. Okay, then if I go in the upward direction, then what happens? If I go in the upward direction, so it cannot rot any orange. If I go in the rightward direction, it cannot. If I go in the downward orange is already rotten. Okay, now I'll go for this particular 2. So I can see that if I go up, no orange I can rot. If I go in this direction, I can, or no orange is there that I can rot. If I go in the downward direction, so there is one orange that I can rot. So basically I'll rot it and I'll store its index as well. So this orange I can rot. If I go in the rightward direction, like leftward direction, so I can rot one orange. So I'll mark it as 2. Now what happens? I can observe that in just t is equal to 1, because what happened, this particular orange will make some effect, right? This was rotten, this was also rotten initially, this was also rotten initially. So this was the first orange, this was the second orange, and this was the third orange. These 3 rotten oranges were there initially, and in time t is equal to 1 only, they will show their effect in the adjacent cells. And now you can see that our grid has completely become, like there were total 4 fresh oranges, but in time t is equal to 1 only, all the fresh oranges have now become rotten. So that's why the output for this case is 1. If we discuss about another test case, so let's say the test case looks like this. Suppose instead of this test case is something like 2, 2, 0 and then 1. If we discuss about this test case, so in this case the answer is actually not possible, because there is a fresh orange, this is a rotten orange, this is a rotten orange, but this rotten orange, since this cell is empty, so it cannot make its effect pass. So that's why this fresh orange will still remain, and in that case if all the fresh oranges are not rotten, so we'll return a -1. Okay, so we can have a counter for this. Now let us try and implement our BFS approach for this particular problem and see what we can do here. So what we will be first of all doing is, we'll be first of all finding the size. So like int n is equal to nothing but the grid dot size. So first of all I'll find the size of the grid. Okay, then what we will do is, like number of rows we have found, now the number of columns. So number of columns will be nothing but grid of 0 dot size. Okay, after this part has been done, so what we will do is, we'll make a queue which will consist of a pair. Why will it consist of a pair? Because we want to store both the indexes I and j for a particular cell. Okay, so it will be a pair of int comma int. Okay, After this part is done, so what we'll do is we'll simply have a counter as well. Like we'll have a count which will be initially marked as 0, that will indicate the number of fresh oranges. Okay, after this we'll iterate through all the cells. So int I starts from 0, I is lesser than n, then I plus plus. Okay, after this what we will do is we'll say that for int j starts from 0, j is lesser than m, then j plus plus is what we will do, and we will simply check that if it happens that suppose that the current grid of I j is 1, right? If it is having a fresh orange, then we'll simply count it, because we want to keep a count, right? In the end, all the fresh oranges should become rotten. Okay, that is the target. Else if suppose that in the current grid cell of ij, if in the current grid of ij, okay, if it's equal to 2, right? So if it's rotten, so in that case what we'll do is inside our queue we'll simply push that particular index I comma j. Okay, now when we come out, so we know the number of rotten oranges. Now what we'll do is we'll say that int, we'll set our timer initially to 0. After this what we will do is we'll simply start iterating. Okay, so how will we iterate? So we will simply iterate the queue. So we'll iterate until the queue is empty. So while the queue dot size is greater than 0, okay, and as I said that we'll be doing a level order traversal. So first of all I'll say that we'll do a time plus plus. Okay, we'll increase the timer, and apart from this also there is one more thing that we need to do. So that suppose if the number, like after a certain point of time, after reducing the number of oranges, like after making the oranges, fresh oranges rotten, if the count becomes 0, in that case we can simply break away from this particular loop. That is also one thing. So we'll keep an update on the timer, otherwise we'll update our timer, and what we will do is we'll iterate for the current size. So I'll take out the size is nothing but q dot size. So I'll first of all take the size of the queue, and then what we will do is we'll iterate until the current level. Okay, because the current level will take the same time, right? If time t is equal to 1, so all the nodes which are there stored in the currently in the queue, they will take only 1 unit of time totally. Okay, so what we'll do is we'll first of all get x is equal to nothing but q dot front dot first. Okay, this would give us nothing but the first value, that is x coordinate, and then int y is equal to nothing but q dot front dot second. Okay, this is how we will get the second coordinate. After this we'll pop out this particular node from the queue. Okay, and then what we will do is we want to move in all the 4 directions, correct? So if we want to move in all the 4 directions, so for that we can use a loop, like we can use some concept that is nothing but the concept of dx and dy. So we can say that dx of 4 is equal to, let's say, -1, then 1, then comma 0, comma 0. Okay, we are using the dx dy concept. Small change in x and small change in y will help us to do it. Okay, so we are marking the dy is equal to nothing but 0 comma 0 comma, let's say 1 comma -1. Okay, this is how we are marking it. Why? Because what we will be doing is, suppose I am currently standing at a particular cell, right? Suppose I use the dx and dy. Suppose my dx is equal to nothing but -1, 1, then 0 comma 0, and suppose my dy of 4 is equal to nothing but 0, 0, then -1 and then 1. Okay, if this is the case, so in this case this will be at the same index as these two. So what is this, right? If you see, this is what, if I'm currently standing at a cell x, so the new x would be nothing but x plus dy of I, because I'll be running in 4 directions differently. So for, I can say that k starts from, let's say I write it as k, so for k starts from 0, k is lesser than 4. Okay, then we will do in k plus plus. Okay, then we will get the updated nx, new x is equal to x plus dx of k. Okay, this will help us update our x, because if we do this, so it will be x minus 1, and then suppose that for y, so new y will be what, y plus dy of k. So suppose if we are currently standing here only in the beginning, if we talk about this cell and this cell, so actually x will be x minus 1 and y will become what, y will be the same. So that means we are moving in the upward direction. Similarly, if we check for this case, so this is nothing but x plus 1 comma y, this is when we are moving in the downward direction. And if we check for this case, so this case is what, this is nothing but x comma y minus 1, that is we are moving to the left direction. If this case we check, so this is what, this case is nothing but x comma y plus 1. Okay, these cases will check. After this part is done, so we will simply do the iteration for the loop. So we will say that for int k starts from 0, k is going to be lesser than 4. Okay, k is lesser than 4, then we do a k plus plus simply, and what we will do here is we will say that the new x is equal to nothing but the x plus dx of k, and the new y is equal to nothing but the y plus dy of y, okay, like dy of k, okay, because k is denoting the indexes. After this part is done, so we will need to check that whether they are valid or not. So if new x, you can write a function for it as well. If new x is greater or equal to y and the new x is lesser than n and the new y is greater or equal to 0 and the new y that we are getting, it is lesser than m, okay. If this is so, then we also need to check that whether it is a rotten orange or not. So if suppose like if it is a fresh orange or not, so if the grade of ij is equal to 1, so that means there is a rotten orange that will destroy this fresh orange. So in that case, I'll mark this grid of ij as nothing but 2, okay, and then we'll decrease our count as well. So we'll do a count minus minus as well, okay. So we'll simply do a count minus minus as well, okay. After this part is done, so when we come out, so we'll check that if the count is equal to 0, so we'll simply break, okay. This is the part that we'll do, and I think that we can return the timer part here. Now this is the time taken. Let us check that if there is something that I might have skipped. So what I've done is, first of all, I have declared this -1 1 0 1 here. Then I've taken the size of the grid, I've taken n and m. Then what I've done is I've taken the pair, I have the int count, where like then I'm iterating through the grid, and if a particular cell is 1, I'm counting it. If a particular cell is 2, then what I'm doing is I'm pushing its indexes inside the queue. After this, I'm iterating through, and if the count becomes 0, so I'll simply break, otherwise it'll increase the timer, okay. After this part is done, so we can say that size is equal to q dot size. Then we are iterating, then we are taking it out, and we are iterating in all the 4 different directions. So if the new x and the new y is in the range, if new x is greater or equal to 0, new x is less than n, and the new y is greater or equal to 0, new y is lesser than m, grid of nx and ny, right? The new x and the new y is equal to 1, okay. In that case, I will mark the new x and the new y as nothing but 2, okay. I'll dot this orange, okay, and I'll insert, apart from this, I also need to push it. Now I also need to push the new x and the new y inside my grid, okay. After this part is done, so when I come out of the function, so there will be 2 circumstances. If either I could come out because the queue is empty, or the count becomes 0. If the count becomes 0, then that means that we have rotten all the fresh oranges and we can simply return the time. Otherwise, if that is not so, so in that case, we will simply return a -1, indicating that the count does not become 0. So that means some oranges were left in the end that were not rotten. Let us try and compile this code and see if there is any error in our code or the approach. Okay, so we are getting an error. So what does the error say? It says that in the line number 45, we are making some mistake. Okay, so we might have missed something here. It says that dx of dy, okay, expected before and, okay, so I need to write and here simply. Let's try and compile it now. So you can see it is working on the sample test case. Now let us submit this code as well. So you can see that we have successfully solved this particular problem. And talking about the time and the space complexity of this problem, so since we are iterating through each and every cell almost, so the time complexity will be nothing but order of n cross m. And since we are not using any extra space, not any extra space, not any visited arrays, so the space complexity for our approach would be order of 1. In case if you understood this explanation, so make sure to comment down understood and also like the video. Thank you.